trash in your video?
I shouldn't be throwing trash in here.
How accurate is this?
This is
Plus or minus a foot up to like 25,000 feet or more. It's a solid out there. So that thing's about 80.
How you correct fracks?
Well, what happens is as soon as you put the battery in, it turns on, right? And right then it takes that as a zero reading, whatever that pressure is. So from there on up, it just measures the pressure and
could vary a little bit.
Yeah, exactly. As long as it's not really quick change.
Want
to do another? Hey, buddy. Hey. I need to. You want to do another?
You go get.
Do another? You guys do another one.
Let's
take a picture of
Oh, all right.
Fast enough to just poke a hole with a steel stick.
You can fly it, go ahead. Thank you for asking.
Actually, you're kind of playing around with the idea of taking a rocket about the size of that hand grenade one.
Okay.
And like, all right, we could basically make a
Water rocket?
a system.
Yeah.
No, the electromagnetic. Like, we realized the energy
I've done this
is
before, but with a
incredible,
different
but we were thinking like
Oh, yeah?
a horizontal, just like runway, and
that,
just a
that was hooked
gradual
up to
vertical.
pipes like that.
Like, what would that take?
Huh.
Would we actually?
Yeah,
You
we.
would need
They
some
were plastic.
substantial electromagnetic coils.
Yep.
Wow, this is a pretty elaborate system.
I love hearing people say that.
He made it.
Cool.
Yeah, you can do any of this stuff. I wouldn't say everything.
Go ahead.
Pull all the way up.
Did you do one of the astrophysics labs over the summer too, or no?
I'm going to go.
The big one do like the bottom of the.
like bottom label.
It's completely unstable.
Oh my god, the water's so warm.
Sarcasm?
It's really warm. It's like hot.
Hmm.
All right, go ahead.
Yeah, those I had 5.
Yeah.
We have to leave now.
The shipping is the reason I had to really throw this thing together. I ended up shipping so I didn't get the black pieces and the white valve until last week.
Oh, really? Oh, bummer.
Why not get it set up?
Well, I put my
We're filling it up. So patience. No, it doesn't matter.
You're gonna do that one?
Oh, bummer.
the common sense just kept
Homemade little setup here.
didn't sell me.
Oh.
You're doing that big one on there?
Yep.
Wednesday,
Pump it up too. If you want.
Oh, that is
It's harder though. I'll help you this time.
I had no time to really follow up.
Don't pump it yet.
Well, it sounds like looks like it worked.
Put
Anyway.
your finger.
Or
Yeah.
what would you have done differently?
Ideally, I would have.
Hold on, don't pump it yet.
I like the guide wire.
Like prizes, they like to compete for things, and there's a history of prizes to get things done. Does anyone know the first man to fly across the Atlantic? Any of the adults? Yes, Charles Lindbergh. And he did so to compete for a $25,000 prize, which is the shuttle. And SpaceX, a private company that's just about to start it either this year or early next year, is going to be doing it for a fraction of that price, a third cheaper. Yeah, so how do you get a rocket on the moon, or a robot on the moon? Well, you need a big rocket. And the thing that I want to stress to you is that this model right here is a Penn State's Lunar Lion rocket. But this is only the tip of the rocket. This isn't the whole thing. This would be similar to what you see up here, only the last 10 or 15 feet of the rocket. There's a whole big section of the rocket because it takes so much energy to get to the moon. The moon's a 250,000 miles away.
Second stage propulsion is performing nominally.
But starts to do that. So our craft has rocket engines right here, here, and there, and it also has another 4 in the other plane. So if we want to rotate, we fire opposite thrusters. So I'm going to show you this model on the bottom of it. So these propellers can spin. So if we want to spin around in a circle, you have to keep your hands out of the water, please. It'll move the system. So if we want to spin, we turn on the opposite thrusters, and that allows the craft to slowly maneuver. You don't want to do anything in space. I know we're flying very fast, but you don't want to make quick movements relatively. So this will how you spin in a circle, and if you want to go the other way, once this works, there we go. And you put on the opposite thrusters, and we'll start to spin around the other way. Then, if we want to move in one direction or another, you can turn on both of these, and this will push us to the side.
I'm sorry, you're going to do this in space or you're going to do this on the moon?
In space. This is how we orientate. There's I don't know why the computer just stopped dying. I had to improvise a lot here. There's some more videos that explains a little bit more of what I'm talking about. But this is how you move in space, because this is essentially, when it's on the moon, it's going towards the moon, it's going to be floating. And how do you want to be able to twist, you want to be able to turn, you need to turn towards the sun, you need to turn towards the earth for different communication purposes. And so you have to have rocket thrusters to do that, because there's no water in space, there's nothing to push against. If you're on the ground and you in a car and you want to go fast, you press on the gas and that makes the wheels spin. The wheels spin and pushes the ground backwards, pushes the car forward.
Ground reaction.
Right. So this, instead of having little propellers, we have little rocket thrusters. And so yeah, you can turn on, as long as you're just turning on these, you can carefully turn on these and see how different combinations make it spin. So if you have both of these, it's just going to be pushed in towards the wall. It takes a little bit of time, so you have to keep the same ones on for it to be the proper movement. I want to see if I can get that working. So also this model.